Welcome to Maths and Science by IITIAN channel. In this lecture, I will be taking up matrix multiplication. Let us try to understand what is matrix multiplication. If there is a matrix A and matrix B, when they are multiplied, what happens? And as far as addition, subtraction is concerned, we have already discussed in the previous classes. Now in this lecture, we will take up matrix multiplication. Let's proceed further. Let us say a matrix A is there. A11, A12, A13, A21, A22, A23, A31, A32, A33. One matrix. And another matrix B is there. B11, B12, B13, B21, B22, B23, B31, B32, B33. When they are multiplied, A into B, what happens? The first element of the multiplied matrix will be sum of the multiplications of first row elements with the of the first matrix with the first column elements of the second matrix. It is a 3 by 3 matrix. It is a 3 by 3 matrix. Here number of columns in A, that is 3, and number of rows in B, that is 3. These both should match. Then only we can multiply. I will do 1 or 2 elements and remaining elements you do it. First element will be first row of A multiplied with first column of B, first column elements. That is sum of them. A11 into B11, A11 into B11, A12 into B21, A13 into B31, plus A12 into B21 plus A13 into B31. Now, what will be the second element in the combined multiplied matrix? A11 into B12, A11 into B12 plus A12 into B22, A12 into B22 plus A13 into B31. Similarly, it happens for all the elements. Now, like this, we will have another 3 by 3 matrix. Total 9 elements. Again, here A11 into B13, next A11 B13 plus A12 B23 plus A13 B33. That means the row elements of the first matrix will be multiplied with the column elements of the second matrix, and all those multiplications will be added as the first element. Similarly for the second element, similarly for the third element in the first row of this. And in the second row, we will start with this. A21, this will be starting second row with first column. That is A21 B11 plus A22 B21 plus A23 B31 similarly. Then next is third. This third will be multiplied with the first column. That is A31 B11 plus A32 B21 plus A33 B31. Like this, all these elements, remaining elements, I have done for 1, 2, 3, 4, 5, remaining 4 you do it as a homework. Mathematics will be learnt by doing it, not by seeing it, not by observing it. We have to do it ourselves. Now, we'll take a simpler case. 2 by 2 matrix. Let A is equal to A11, A12, A21, A22. B is equal to B11, B12, B21, B22. Then what is A into B? This is of 4 elements. A11, B11 plus A12, B21. Next is A11, B12 plus A12, B22. Similarly, A21, B11 plus A22, B21. Next, A21, B12 plus A21, B22. Now in this, for example, a matrix is like this. A is equal to, please pay attention to it. It's very important. A matrix is like this. A11, A12, A13, A21, A22, A23. A matrix can be like this also. It's a rectangular matrix. It's 2 rows and 3 columns. B is equal to B11, B21, B12, B22. Let us say it is 2 by 2. 2 rows and 2 columns. Can we multiply? Is A, B or A into B possible? Tell me. Here, for example, with A11 we can multiply B11. With A12 we can multiply with B21. But what happens to A13? There is no corresponding element in B for that. Because here there are 3 columns and 3 elements, whereas here only 2 rows for multiplication. Hence, until and unless these number of columns in the first matrix is equal to number of rows in the second matrix, you cannot do matrix multiplication. That is one of the most important concept. Number of columns in first matrix should be equal to number of rows in second matrix. This is very important. Example, if A has M into P columns, first matrix. B is P into N. Then, because this P columns in A is equal to P rows in B, number of rows in B, A into B is possible, and size will be, remove this P in between, M into N. It can be shown as A is equal to something of M into P size, and B is of something, some elements, P into N, then these two should be common. The number of columns in the first and number of rows in the second, they should be common, they should have the same value. Then A into B is equal to something, it will be M into N. The size of A into B. This is the first property. This is the first property or first requirement for multiplying two matrices. Next, we have to multiply the row elements with the column elements. Second requirement is multiply and add row column elements of first and second matrix correspondingly. To get A into B elements. That is the second requirement. And third and most important property. A into B is not equal to B into A. Why? Here you see A is M into P, B is P into N. A is M into P size, B is P into N size. That implies A into B is equal to AB is equal to M into N size. What is B into A size then? B into A. B is P into N, A is equal to M into P. Is it possible? B is equal to P into N and A is equal to M into P. There is number of columns in B is not equal to number of rows in A. Hence B into A is not possible. Hence A into B is not equal to B into A. That implies multiplication is not commutative. In matrix operation, Addition is commutative. A plus B is equal to B plus A. Subtraction is not commutative because A minus B is not equal to B minus A. And third property, multiplication is not commutative because AB may not be equal to BA. And find some matrices for which AB is equal to BA. That is your homework. May not be, but there can be. If A and B both are null matrix, then AB is equal to BA. Homework, find a matrix A and B such that AB is equal to BA. Null matrix. Null matrices. Because in null matrix what happens? A is equal to 0, 0, 0, 0. B is equal to 0, 0, 0, 0, which implies AB is equal to BA. That means AB is equal to BA commutative for two null matrices, but not otherwise. Even subtraction is commutative for null matrices, but not otherwise, but not for other matrices. Please understand the concept. Now, let us take interesting matrices, that is Pauli matrices. Pauli matrices, why I am repeatedly giving examples in almost all the classes of matrix operations, because they are very important matrices in modern physics, quantum physics and physics theories. Let us say they are traceless matrices. If somebody says what is a traceless matrix, that means the sum of the diagonal elements is equal to 0. That is a traceless matrix. Pauli matrices are very famous traceless matrices. And one of the Pauli matrix, let us say 1, 0, 0, minus 1. This is one Pauli matrix. And what happens? Sigma into sigma, that is sigma square. What happens? Let us see. 1, 0, 0, minus 1 into 1, 0, 0, minus 1. That is equal to 1 into 1 plus 0 into 0. 1 into 1 plus 0 into 0, first element. Second element in the row, 1 into 0 plus 0 into minus 1. In the second row, first element 0 into 1 plus minus 1 into 0. Fourth element 0 into 0 plus minus 1 into minus 1. If you do it, sigma square is equal to 1 plus 0 is 1. 0 plus minus 0 is 0. 0 minus 0 is 0. This 0 minus 1 into minus 1 is plus. That is I. That means the square of the Pauli matrix is a unit matrix or an identity matrix. You just see. Pauli matrix is a traceless matrix. But square of the Pauli matrix is not traceless. It is a unit matrix. It's an identity matrix or a unit matrix. And we know there are three Pauli matrices. What are they? 0, 1, 1, 0, and second Pauli matrix is 0, minus I, 0. Third Pauli matrix is 1, 0, 0, minus 1. If this is A, this is B, and this is C. Try to prove or try to understand one commutation property. Among these matrices, are they commutative? Is AB is equal to BA? Is BC is equal to CB? Or AC is equal to CA? That means find if AB is equal to BA or AC is equal to CA or BC is equal to CB. Which of them are commutative? Then, can you develop a relation between A and B and C? This is your homework. Develop a relationship between A, B and C. I have already given enough of theory to you. You please try to do homeworks like this so that you will better understand what are the matrix operations. Addition we have done subtraction we have understood, and we have understood the commutative property of addition, subtraction and multiplication. In this class we have done the multiplication. And in the next class we will be doing inverse. Inverse matrix is itself a very important and also very lengthy. There are many ways of finding the inverse of a matrix, and I will discuss one by one in number of lectures, following lectures, because there are many ways to find the inverse. There is not a single method to find the inverse. We can find the inverse of a matrix, and I will give the shortcuts also how to find the inverse of 3 by 3 matrix very easily, 2 by 2 matrix very easily, so that very fast you can find out the inverse of it. There are many methods. You can apply a particular method and you get the answer easily. Then before going into the inverse, we have to understand the determinants. Without understanding the determinants, we can't understand the inverse of a matrix. We will go for determinants. We will start classes on determinants from next class onwards. And with this, I want to stop this lecture now, and best of luck to everybody. Thank you for viewing my lecture. And addition, subtraction, multiplication, I think it is clear to all of you, and try to see my videos repeatedly. If you have any issue on understanding the subject, and from next class onwards we will be taking up very important topic of determinants. It has both engineering, physics and lot of applications, determinants. After knowing the determinants, then we will go into the inverse of a matrix. Best of luck to everybody. Thank you for viewing my lecture, and please, if you feel there is a value addition to you because of this lecture, kindly share my videos and also kindly subscribe to my channel Maths and Science by IITIAN. Thank you. Best of luck.